Our next topic in the section on patterns of growth is on exponential growth. So in linear growth, we talked about the idea that we were growing by the same constant amount each time. And when we talk about exponential growth, we're going to talk about how we grow in a different way. And so usually what we're going to talk about with exponential growth is either growing by a fixed multiplier or by a fixed percentage. And these are actually the same thing. So these are not anything different. So when something grows exponentially, it grows by a fixed multiple, right? Like you might say it doubles every hour, right? That's a fixed multiple. What that means is that it multiplies by 2 each unit of time, or grows by a fixed percentage of the previous amount. So something like grows by 3% each year. Okay, and so in either of these situations, these are really the same thing. They're just different ways of talking about exponential growth. So unlike linear growth, where we increase by a constant absolute change each time, this is a constant relative or percentage change. Okay, so this is increasing by the same percentage, by the same multiplier every single time. Okay, so let's look at a situation, and then we'll talk about the equations and how to solve problems. So let's say that population of lions is 1,000 and grows by 3% each year. Okay? So this is exponential growth. We're not going to actually grow by the same amount each year, because if you think about what happens, so year population, we start at year 0 with 1,000, and then in year 1 we grow by 3% of that 1,000. So 3% of 1,000 is 30, and so we're going to have 1,000 plus 30, so 1,030 lions. Now, if this were linear growth, we would grow by 30 lions the next year, and 30 lions next year, right? But in exponential growth, now we're going to grow by 3% of this new value, 1,030, which if you take 3% of 1,030, you're going to get 30.9. So we're going to round up to 31, right? So what we would get in year 2 is 1,030 plus 3%, 0.03 of 1,030, which is 1,061. So we've grown by 31 lions now instead of 30. We haven't grown by the same amount. We've grown by this fixed percentage. In year 3, we're going to have 1,061 plus 3% of 1,061. And that's going to take us up to 1093. And we can keep going like this, right? So the next year we would have 1093 plus 3% of that, we'd get 1125. And so you can see here the absolute change each year. If you look at what you're changing by each year, the first year you go up by 30. Why do I have? Oops, I have erased too much. Confused myself. So the first year you go up by 30. The next year you go up by 31. Then by 32. Then by 32 again. Right? Some of this is rounding error. But the amount that you're going up by is always 3% of the previous amount. Okay? And so that's what we mean by exponential growth. We go up by a fixed percentage or a fixed multiplier. Okay? So how does this look in terms of our recursive and explicit equations? Right? Because that's what we really need to solve problems. So if we want to set up our recursive equation, it's going to set up very similar to what we had before. We're going to have some, let's call our variable p here, some initial amount, p sub 0 equals our initial value. So in this particular case, p sub 0 equals 1,000. And then the other piece is we need to think about how do we go from one value to the next. Okay? So p sub n is going to be equal to the previous value plus some fixed percentage of the previous value. Okay, so say we grow by r percent, percent written as a decimal here, you're going to get the previous amount that you had, p sub n minus 1, plus that previous amount times your percentage growth rate. Okay, so in this particular example, p sub n equals p sub n minus 1 plus p sub n minus 1 times 0.03. Okay, so these two pieces together are your recursive equation in this particular situation. And it's always going to look like that. It's always going to be p sub 0 is your initial amount, p sub n is p sub n minus 1 plus p sub n minus 1 times the percentage. And all that's saying is that if you want to get the next value, take your previous value, add to it your previous value times the percentage growth rate. Okay? So another way to write this that's related is you can write it instead as p sub n equals p sub n minus 1 times 1 plus r, where r is your percentage growth rate. I've just grouped these two terms together. This 1 plus r now is our constant multiplier that we're going up by, right? So each time we can think of either taking the previous value, adding the previous value times r, or we can just think of taking the previous value times 1 plus r, okay? It gets you the same thing, okay? And so that's going to be useful in talking about our explicit equation, which is next. Because if you want to think about the explicit equation, which again, as always, is the more useful one, what you're going to have is that p sub n is your initial amount, p sub 0, times 1 plus r to the n power. Okay, and this is where exponential growth comes from. This is called an exponent. And that's because if you think about what happens with your growth, right? We started at 1,000, so 8p sub 1 was 1,000 plus 0.03 times 1,000, 1030, right? That's how we got it. Well, that's the same thing as 1,000 times 1.03. If you want to go to the next year, p sub 2, you're going to take this value and multiply it by 1.03 again. Multiply it by the same multiple. So 1,000 times 1.03 times 1.03. Well, to get the next one, p sub 3, 1,000 times 1.03 times 1.03, the previous value multiplied by the same thing, 1.03. And so you can see how you start to get p sub 2 is 1,000 times 1.03 squared. P sub 3 is 1,000 times 1.03 cubed. P sub 4 is going to be 1,000 times 1.03 to the fourth, and so on and so forth. Okay? And so what we get is if we have exponential growth growth rate, percentage growth rate, sorry, percentage growth rate R, our recursive equation is going to be P sub 0 equals our initial value. P sub n equals P sub n minus 1 times 1 plus R, where R here is written as a decimal. And then our explicit equation is going to be P sub n equals P sub 0, our initial value, times 1 plus R to the n. Okay? And so we can find our initial value, find our percentage growth rate, and then find either of these equations. And what we'll do in the next video is talk about how to solve problems with them using these examples.